by Ramesh Babu, author. Reference book. So in the last class, inverse Fourier transform using long division method or power series method and partial fractional methods we completed. Okay. In partial fractional method, only one problem I have solved, but in Laplace transform we solved many models, simple pole or pole with a multiplicity of 2, 3 or ax square plus bx plus c format. So the model problem we covered. So in Z transform, I solved only one problem. Okay. Next one. Determine the signal x of n whose Z transform is given by x of z equal to log 1 minus a z power minus 1. So this is some standard problem. Many times this question is repeated in the semester exams. Okay. This also inverse is a transform. We have to find out x of n from x of z. But we cannot apply any the methods that partial fractional or power series or residue or convolution. That method not applicable to solve x of n from x of z equal to log of 1 minus a z power minus 1. Okay. Using properties, we are going to solve this problem. So remember these two property. If x of n z transform result is x of z, then n times of x of n z transform minus z d by dz of x of z. This is one formula. Another formula, time shifting property. X of n, x of z. X of n minus 1 z transform result z inverse of x of z. N minus 2 z power minus 2 x of z. So using these two property, we are going to solve this x of n from given x of z. Okay. So x of z given. So try to obtain the expression minus z d by dz. First d by dz. D by dz of x of z. X of z available in the problem. Log 1 minus a inverse. Log x 1 by x. 1 by x. 1 by 1 minus a z inverse. 1 divided by 1 minus a z inverse. Again, you have to differentiate this particular term. So you will get a z power minus 2. Okay. So d by dz of x of z. Next, multiply with minus z. So minus z d by dz of x of z. Your result is minus a z power minus z. So z power minus 2 becomes z power minus 1. Minus a z power minus 1 divided by 1 minus a z inverse. Or can we rewrite this particular expression minus a z inverse 1 divided by 1 minus a z inverse? The reason is 1 divided by 1 minus a z inverse. This is the result transform of a power n u of n result. Okay, that's why I have rearranged this 1 minus a z inverse. So in the next step, minus z d by dz of x of z equal to minus a z inverse. This is nothing but z transform of a power n u of n. Okay, z transform of a power n u of n result is 1 divided by 1 minus a z inverse or z divided by z minus a. Both are same. Okay. So we got the equation for minus z d by dz of x of z. Okay. But in this example, z power minus inverse also available. So using the time shifting property, z inverse of x of z. Z inverse of x of z. What would be the result? Z inverse of x of z. That is equal to Z transform of x of n minus 1, right? If we find the inverse Z transform. So what I'm going to do, minus A Z transform of a power n minus 1 u of n minus 1. Okay. So this equation would become like this. If we apply this time shifting property, Z transform of x of n minus 1 equal to Z inverse of x of Z. So in this example, you assume this is your entire x of Z. Okay, this is your entire x of Z. So Z inverse of x of Z. Result is Z transform of x of n minus 1. Z transform of x of n minus 1. X of n a power n u of n. So n minus 1 u of n minus 1. Okay. So finally, we obtain the expression this one. So compare this equation with the standard property, that is Z transform of n into x of n. Let consider this is equation number 1, this consider this equation number 2. So this is property. Okay, properties of Z transform. We have to find out x of n now, right? We have to find out x of n. So as per the property, from equation 1, 2, n into x of n. N into x of n is equal to minus a is a constant, minus a power n minus 1 u of n minus 1. Minus a power n minus 1 u of n minus 1. Okay. So x of n equal to minus a power n minus 1 u of n minus 1 divided by n. This is the result. Okay. So this problem is important for the semester exam. You may multiply this minus a inside. Further, you can simplify this. So you will get minus a power n u of n minus 1 divided by n. Okay. So using properties also, we can find the inverse is a transform. So I think only one problem available in your textbook, signals and system Murugapandiyan, and that problem is this one only in the example problem. Okay. So inverse is a transform, partial fractional method, power series method, and using properties, only one problem we have solved. The last method, residue method. You may studied this residue theorem or residue method is a transform in your mathematics, correct? Have you studied in this semester?
Yes, sir.
Okay. Residue method. So usually the inverse is a transform, fundamental formula 1 divided by 2 pi j. Comparing Z transform and DTFT, there is a separate derivation available. It's a closed contour x of z power n minus 1 dz. So this is actually inverse is a transform formula, but we are not going to use this particular formula. Okay. Now residue theorem state C is a circle. C is a circle in the Z plane. In the Z plane, in the region of convergence of x of Z. Okay. So residue theorem says your x of n can be obtained from summation residue of x of z into z power n minus 1 at the poles inside the circle. At the poles inside the circle. Or mathematically, if you represent this concept, x of n equal to summation I z minus zi into x of z power n minus 1 z equal to z. So this is the standard formula we are going to use for finding the inverse z transform from the given x of z. Here zi represent poles. Maybe one pole or two pole or three pole. So while solving the problem, you can understand what it represents, this particular expression, summation I z minus zi, then x of z multiplied with z power n minus 1. Because in the last semester AC department semester paper, they have mentioned clearly, using residue method, find the inverse z transform. If nothing is mentioned, you can go with partial fraction. That is the best suggestion. If the specific method is described in the question paper, then you have to go with that particular method only. So first problem in the residue method, x of z equal to 1 plus 3z power minus 1 divided by 1 plus 3z power minus 1 plus 2z power minus 2. Find inverse z transform for the region of convergence modulus z greater than 2 using residue method. Okay. First convert this expression into z power series. So multiply z power 2, both numerator and denominator. You will get z square plus 3z divided by z square plus 3z plus 2. If you multiply both numerator denominator by z square, you will get this expression. So take z outside, you will get z plus 3 for plotting the zeros. And denominator, multiplication of two number 2, addition of two number 3. So that is z plus 1 into z plus 2. You will get this. Okay. So first step in the problem, you have to convert the given x of z to this. Factorize this. Factorize the given x of z. Now apply the residue theorem. What residue theorem says? X of n equal to, in this example, summation residue of z plus 3, z plus 1, z plus 2. This is entire x of z, right? Multiplied with z power n minus 1. At poles, z equal to minus 1 and z equal to minus. There are two poles, z equal to minus 1 and z equal to minus 2. Okay. How to solve this? First step. Residue of, for z plus 1 equal to 0, for this particular pole, we should solve. I'll directly write down. Why again residue? Two poles are there. Z equal to minus 1. So this will be equal to z plus 1 z into z plus 3 divided by z plus 1 z plus 2 as per the formula z power n minus 1. At z equal to minus 1 plus summation plus z plus 2 z into z plus 3 divided by z plus 1 into z plus 2 z power n minus 1. After solving, replace z by minus 2. That's the meaning of this statement. Summation residue of x of z. Summation residue of x of z multiplied with z power n minus 1. Okay. So in this example, only two poles are there, and these two poles are simple pole in the order of 1 only. If order 2 if order 3, then we have to do some small modification. I'll tell you what to do it. So z plus 1 cancel, 2 will be cancelled. So z multiplied with z power n minus 1. Z power 1, z power minus 1 cancel. You will get z plus 3 into z power n divided by z plus 2. Substitute z equal to minus 1 plus here also z plus 3 z power n is the leftover part z plus 1 and substitute z equal to minus 2. So this is your result. Two poles. What is the given ROC? Greater than 2. A circle with radius 1, a circle with radius 2. So ROC is outside of outermost circle. So you have to write your answer in terms of causal signal only. That's very important. Okay. In this example, ROC given two poles z equal to minus 1. Z equal to minus 1, one pole. Z equal to minus 2, another pole. ROC given modulus Z greater than 2. Outside of outermost circle. Okay, outside of outermost circle. So outside of outermost circle meaning your x of n must be a causal signal. Okay. So write down z equal to minus 1, minus 1 plus 3. So you'll get 2. So 2 minus 1 power n. 2 minus 1 power n divided by z plus 2. 1 only. Plus substitute z equal to minus 2, 3 minus 2, 1. So minus 2 power n. Minus 2 plus 1 will get minus. So this is your x of n result. But modulus is greater than 2. Okay. So we always write x of n result in the form of causal. So 2 minus 1 power n minus 2 power n u of n. Okay. So this is your final answer. Same answer you will get if you solve using partial fractional method also. You may expect the problem, solve using residue method and solve using partial fraction method, compare your result. Okay. Why I put u of n? The given ROC condition is outside of the outermost circle. So we already studied. If ROC is outside of outermost circle, the signal must be a causal signal. Already we have proved, right? A power n u of n minus a power n u of minus n minus 1. Okay. So this is a residue method of solving inverse Z transform. Okay. So what are the difficulties in this particular residue method? If order is 2 or if the order is 3, then how to solve it? Second example I'll give you. Okay. Example 2. Find the inverse Z transform using residue method. 2z power minus 1, 1 minus 1 by 4 z power minus 1 whole square. Modulus of z greater than 1 by 4. Okay. Find inverse Z transform. So what I suggested first, convert your x of z in the form of z divided by some format. So multiply z square on both numerator and denominator. You will get 2z divided by z minus 1 by 4. Okay. Now z equal to 1 by 4 is a pole, but multiplicity of 2. Or in the order of 2, right? Z minus 1 by 4 whole square. Then how to solve this problem? Using residue method. Same procedure. Suppose in this example, one pole in the order of 2, another pole in the order of 1. In order of 1, no issue. We have to solve in the previous method only for that particular pole only. For that particular section, follow this procedure, right? Here two poles are simple pole. So we are following the residue using this part and using this part. Suppose order 2 also there and order 1 also there. Then order 2 you follow one method and the simple order follow the previous method. Okay. Let us complete this first. Now the formula x of n equal to 1 divided by n minus 1 factorial. General formula 1 divided by n minus 1 factorial d by d set of n minus 1 x of z. Previously simply we put x of z. Now 1 divided by n minus 1 factorial d power n minus 1 divided by dz power n. Dz power n minus 1 factorial. Okay. Then x of z power n minus 1 z equal to z. Summation residue of. This is for the part. If any pole having multiplicity more than 1, then for that particular section only we have to use this procedure. Okay. So order 2, 1 divided by 1 factorial. So d by d set only. D by d set only. X of z power n minus 1. Finally, we have to substitute z by 1 by 4. Do some modification here. x of n equal to summation, general formula. Residue of. Okay. So while solving, d by d set of z minus 1 by 4 square into x of z. What is x of z given? 2z divided by z minus 1 by 4. 2z divided by z minus 1 by 4 square multiplied with z power n minus 1. Finally, replace z equal to 1 by. Okay. What is this small modification here? Previous problem all are simple pole. So directly residue of each and every pole. Here order 2. So follow the procedure 1 divided by n minus 1 factorial d power n minus 1 divided by dz power n minus 1 x of z power n minus 1. Okay. So first multiply with this term will be cancelled. Multiply with x of z with z power n minus 1. So z will be cancelled, right? You will get 2z power n. 2z power n. That's it. Z equal to 1 by 4. Differentiate. 2 n into z power n minus 1. Z replaced by 1 by 4. So 2n 1 by 4 power n minus 1. This is your result. Okay. So what I told you in the beginning of this problem, suppose let assume in this example one more pole is available here. I'll show you. Note x of z equal to 2z. 2z divided by z minus 1 by 4 square. Then z minus 1 by 2. So how to solve residue method using this for this particular problem? A pole z equal to 1 by 4 with a multiplicity of 2. A pole at z equal to 1 by 2, but order is 1 only. So in this example, x of n equal to 1 by n minus 1 factorial d power n minus 1 divided by dz power n z minus zi x of z power n minus 1 and z equal to z for this. Okay, plus simple. Okay, one only available, n minus 1 factor, 1 minus 1 0 factorial. No need to apply that. First problem method directly we will solve it. Z minus zi x of z power n minus 1 and z equal to z. Second, understand? If x of z given like this, then you have to solve for the pole z equal to 1 by 4. Follow this method. For the pole z equal to 1 by 2, follow this method. Right? Previously separately we discussed example 1 and 2. So I'm giving the hint for you. In the examination, if the problem comes in this particular format, they have to solve in this method. Okay. So example 3, x of z equal to z power minus 1, 1 minus 2 z power minus 1, 1 minus 3 z power minus 1. Now the region of convergence given 2 to 3. First example, modulus z greater than 2 outside of outermost circle. So we have written answer in terms of causal signal. Okay. Now ROC given greater than 2. It must be a causal signal. The result of this, the term 2 in the pole, it must be a causal signal. Modulus z less than 3. Inside the circle, it must be a non-causal result. While writing the result, you have to write it properly. So convert, just multiply z square on both numerator denominator, you will get z divided by z minus 2, z minus 3. Two poles are there, both are simple pole. So x of n equal to z minus 2, z divided by z minus 2, z minus 3 into z power n minus 1. Replace z equal to 2 plus z minus 3 z divided by z minus 2, z minus 3, z power n minus 1. At last, replace z by 3. Okay. 2 will be cancelled. This term will be cancelled. So z multiplied with z power n minus 1, z power n divided by z minus 3. Okay. Plus z power n z minus 2. So replace z by 2 in the first term. Your inverse is a transform result 2 power n and 2 minus 3. So minus 2 power n plus 3 power n. Is that equal to 3? 3 minus 2, 1. Okay. Now ROC given, no? So we should write the answer properly. Modulus is n between 2 to 3. Z is greater than 2. So this particular term minus 2 power n e of n. Write in the form of causal signal. Okay, because we proved already, if a signal is causal signal, the ROC is outside of the circle. We already proved, right, in the Z transform beginning of the classes. Next, modulus of Z less than 3 inside the circle. Definitely the x of n must be a non-causal signal. So the result is minus a power n u of minus n minus 1. Minus a power n u of minus n minus 1. So minus 3 power n u of minus n minus 1. So this is your result. For given ROC, we should write the result in the proper format. Okay. So simple and pole periodicity more than one, combination with simple pole also how to solve it, and order 2 how to solve it. Okay. In order 3 also you have to follow the same procedure. 2 times you have to do the differentiation. So I'll check any problems are there for order 3. Okay. X of z equal to z divided by z minus 1 cube. Okay. ROS is not specified. If ROS is not specified, you always write your result in causal signal format one. Now only one pole but multiplicity of 3. Okay. Using residue method, x of n equal to 1 divided by n minus 1 factorial. Order 3, 3 minus 1 factorial, 2, 2 factorial. D by dz of n minus 1, 2. Okay. Then z minus 1 cube into x of z. Z divided by z minus 1 multiplied with z power n minus 1. And finally, z replaced with 1. Cancel. 1 by 2 factorial 2 d square by dz square. Z 1 minus 1 cancel, z power n. 2 times you have to differentiate. Z power n. N into z power n minus 1. First term. 1 by 2. Again differentiate. N minus 1 into z power n minus 2. So replace z equal to 1. One by 2 n into n minus 1, 1 power n minus 2. Okay. So your result is n into n minus 1 by 2. Or you can stop at this particular step. ROC is not specified, so you stop at this particular step, x of n. Okay. So I think we covered all the problems. Is a transform, basic problem also, as well as problems using properties and relation and stability checking. Okay. So stability checking, already we solved the problem, right? Stability criterion. Okay. So stability criterion for discrete time LTE system, summation n equal to 0 to infinite must be less than infinite for DT LTE system, right? For DT LTE system, the condition for stability. Okay. In Z transform, how to find stability? Find out h of z. Okay. N equal to 0 to infinite should be less than infinite. So this is equivalent to modulus z equal to 1 for unity circle. Okay. So I'll show you some example. From that you can understand easily. Because in the previous class, I told you stability of LTE system. How to check relationship and before the relationship. Right. So all the poles lies within the unity circle. The LTE system is stable system. So that is the condition for stability. Okay. This for your knowledge only. We begin Z transform with the problem x of n equal to u of n, right? What is the Z transform of this? We find Z transform, our result is Z divided by Z minus A. Modulus of Z is greater than A. Okay, A power n u of n. So if you try to sketch this signal A power n u of n, your signal will go like this, right? N versus h of n. Okay. So in Z domain, when you will get this kind of signal? If A is less than 1, correct? If A is less than 1, then only you will get this signal. If A is less than 1, that is 1 by 2 some value, then you will get decreasing exponential. So if you find Z transform of the signal, the pole must be lies inside the unity circle. Okay. So this is in time domain. Say for example, 1 by 2 power n u of n. 1 by 2 power n u of n. What is the Z transform result? Z divided by Z minus 1 by 2. Pole Z equal to 1 by 2. 1 by 2 lies within the unity circle, right? So 1 by 2 power n u of n is a stable system. Suppose h of n, the impulse response of the LTE system is 1 by 2 power n u of n. This is a stable system, we know. Summation 0 to infinite a power n. We will get finite value, so this is stable system. But now the question is, how to identify stable system from Z transform result? Okay, if some x of Z given like this, or h of Z given, h of Z equal to Z divided by Z minus 1 by 2. Now how to check stability of the system? Then we should follow this method. If the poles lies inside the unity circle, then it is a stable system. Okay. Suppose if any poles lies on the unity circle, then you write the statement marginally stable. This is single signal, so I written if a pole lies inside the unity circle. CL. Then the system is stable system. Suppose if A is greater than 1, meaning what is your signal? Let h of n equal to 2 power n u of n. It's a stable signal. Plot n versus h of n. It's unbounded, right? It's unbounded signal. It reaches infinite at n equal to infinite, right? So this is unstable. From h of n we can directly comment, but from Z transform how to check? Suppose if h of Z equal to Z divided by Z minus 2. Assume h of Z equal to Z divided by Z minus 2. So now first draw the unity circle with the radius 1. Is that equal to 2? 2 is outside of the unity circle. Okay. Therefore unstable. Understood? That is the reason while solving the problem I suggested to check whether the system is stable or unstable. We have to check the poles. If all the poles lies inside the unity circle, then it is stable. If any poles lies on the unity circle, then it is marginally stable. If any single pole lies outside the unity circle, then it is unstable system. Okay. So these are some basic concepts just for your understanding purpose only.